Okay, guys, welcome back. Today is February 1st. So we're going to place the date down of what we have written. This is what we saw yesterday. We left the empty space for the topic. We defined slope. We saw the formula m equals y2 minus y1 over x2 minus x1, in which you need 2 points, okay, two order pairs. We saw the definition or how it's written a slope-intercept form. We saw the 4 types of slopes. We didn't say that for the slope-intercept form, B represents this point where the line touches the y-axis. And as you can see, this line does not touch the y-axis. That's why it cannot be a non-vertical line, okay? It cannot be a non-vertical. It has to be a vertical or an inclined line because it does not have a y-intercept, okay? We did some exercises. We determined that a positive slope is inclined to the right, a negative slope is inclined to the left, zero slope is completely horizontal, and an undefined slope is completely vertical. We said that a zero slope has a 0 in the numerator and an undefined slope has a 0 in the denominator, okay? So what are we going to do today? We're going to continue with this part of the topic, the second part, okay? So let's place a date. And today's February 1st. First day of the second month of this 2022. Okay, so what are we going to see? Slope-intercept form equations. So if I have an equation that is, for example, written in the form y is equal to 2x plus 3, we can determine, since it has the variable y completely alone, we can determine that the number right next to the variable x will be the slope, okay? In this case, it is the number 2, okay, because it is y equals mx plus b. I'm gonna write it over here. We can also determine that b is the constant. In this case, it is 3. We are always going to write this number as a y-intercept because it is a y-intercept. Therefore, it's going to be 0. Always the 0 goes first, comma, and whatever number you get, including the sign in front of it. In this case, it is positive 3, so it is positive 3. Now, there's something important that you need to know when we are going to get to graph this. When I move this, we're going to graph this. And what is it? Is that we need the slope to be a fraction. In this case, do we have the slope as a fraction? No, right? It is not a fraction. How do we make this 2 a fraction?
Put in an invisible 1.
Where?
In the denominator.
Exactly. Placing an invisible 1 in the denominator. Now that is a fraction. Now, in order for us to graph it, we need to determine the rise and the run because they were given us a fraction. So we just need to say, to see if the rise is positive, it goes up. If it's negative, it goes down. In this case, the rise is positive. It means that it has to go up. Up from where, some of you might ask, you will see when we start graphing. The run, if it goes to the right, it means that it is positive, or the other way around. If it's positive, it goes to the right. If it's negative, it goes to the left. In this case, it was an invisible 1. Therefore, it's a positive number 1. It goes to the right. Okay, so what do we do now? Well, we're ready to graph. That's it, miss. That's all that we need. Yes, that's all that we need. We only need the slope and the intercept written in a order pair form. So let's graph it. I'm going to draw my coordinate plane. As you can see, I don't need much number, so I'm doing my coordinate plane small. Okay, small coordinate plane with the arrowheads where I need them. I'm going to graph 0, 3. 1, 2, 3, 4, and I think that I'm going to need it a little bit longer. So I'm going to move it a little bit down. It's here. And this one, I'm going to make it larger or longer. There. Okay, so let's continue with the arrowhead. So that was 1, 2, 3, 4, 5, 6. And I draw my arrowheads. I'm graphing this point, 0, 3. Since it is the y-intercept, it is a point on the y-axis, in this case, on 3. 1, 2, 3. Over there. Okay, so now what do? Now I just go ahead and use my slope. And I'm going to move up or down according to the rise, and to the left or to the right according to the run. So in this case, I'm going up. How many spaces? 2 spaces. From where? From this point. I'm going to say, let's do it in red. I'm going to say 1, 2. Those 2 units up. Then I need to go 1 unit to the right because of the run. You can start with the run or you can start with the rise. It doesn't matter. And I go 1. Exactly in that point where I moved, that's where I'm going to place my second point. And now I just connect those 2 points with a straight line using a ruler. So let's use a ruler. It is easier when you actually have the ruler, okay? So I'm going to pass a line, crossing those 2 points using my ruler. That's my line. I draw my arrowheads, and that is the line that you get using the slope and the intercept only. If you want to try and do it with the input-output table, you will see that it will completely match and get on top of this line that we just drew, okay? It has to be exactly the same. The difference was that we're gonna get 5 points, not just 2. That's the only difference, okay? But you're gonna get those points. Questions? No? That's it. That's the slope-intercept form equation and how you graph it using this second method. Is it too easy, right? So easy. Now let's do another one. Let's do another one. Move the ruler down here. And let's move this to the side. So let's say that we got 3x minus 3x over 2 3 over 2x minus, no, plus 2y is equal to 4. So, question, is this written in slope-intercept form? Is it written in slope-intercept form? Yes or no? Is it written in the slope-intercept form?
No.
No. How do we know? Because slope-intercept form is this, where the y is completely alone and positive in one side. And in here, the y is not alone because to begin with, it is with the x and it has 2. It is positive, yes, but it's not alone. So let's make it slope-intercept form. So this 3/2 x will go to the other side, negative, okay? Since we want to maintain the slope-intercept form, we're leaving the x first and then the constant. So we get 2y is equal to negative 3. Negative in the middle. 3 over 2 x. I'm sorry for this, guys. Today the mouse is not working that much. So plus 4. Am I done? No, I have this 2. Now this 2 needs to go to the other side, dividing because it is multiplying, and we'll go dividing every single number. So I'm going to say y is equal -3. But instead of dividing, just dividing, I'm going to multiply the 2 with the denominator. So 2 times 2, that's 4. X. Okay, so let me see if we're doing it properly. So it goes dividing. Yeah, it's properly done. And we're going to divide 4 by 2. And we can do it mentally. How much is 4 divided by 2?
2.
2. Very good. Now, do we have the slope-intercept form equation in here? Yeah, variables completely alone. I got a number with the x and I got a constant. So I'm going to say, okay, the slope. What is the slope in this case? What is the slope, guys?
-3/4.
-3/4. Very good. Now, since the negative in this exercise is placed in the middle, you pick which is going to have the negative. Is it going to be with the rise or is it going to be with the run? It doesn't matter. At the end, you're still going to have the same answer. So just for you to see that it could be in any place, I'm going to say 3 over -4. That's my slope. And B is my y-intercept. And in this case, I'm going to write it as an order pair from the beginning. So I'm going to say that this is 0, 0, what?
2.
0, 2. Very good. And that is my intercept. So now I'm going to work with my graph. I'm ready to work with my graph. Okay, so I'm going to graph it. Let's make it in block. Okay, so I'm making my coordinate plane. I don't know how long I need to have my coordinate plane, so I'm going to do it that long. Okay, I make my arrowheads because all coordinate plane have to have arrowheads. And I'm graphing the point 0, 2. So where 0, 2 is 1, 2 over here. And as you can see, for you to see, I will start using the run first, okay? In this case, my run is negative. So since it's negative, it goes to the left. And my rise is positive, so it goes up. Okay, so I'm going to the left 2 units. From where? From this point, 4 units, sorry. So I count 1, 2, 3, 4. And I go up 3 units. 1, 2, 3. Right in there is where I need to place my second point. And now what do? I just go ahead and connect it with my ruler. So let's connect it with the ruler. Connected with the ruler in blue. Okay. Make it larger or longer. And I'm gonna eliminate my ruler right now. Draw my arrowheads for my line. And that is my line. And as you can see, this was a positive slope. Okay. This was a positive slope, and you can see positive slopes are inclined to the right. This was a negative slope, and negative slopes are inclined to the left. And that is how you use the slope-intercept form to graph. Any questions so far? Is there any question about this topic? Remember, the first thing is to have your equation in slope-intercept form, which is this one. If you don't have it, like in the second case, you need to make it and transform it into slope-intercept form. Then you identify your slope and you identify your intercept. You graph your intercept first. You identify the rise and the run, if it goes up or down, left or right. And you decide if you're working with the rise first or with the run. And as you can see, it doesn't matter if you pick first the rise. If you pick the rise first, then we go 1, 2, 3, and then the run goes to the left. 1, 2, 3, 4. Same spot. It doesn't matter if you pick first the rise or the run. At the end, you're getting the point exactly in the same position. Is there any question? Okay, now we can place the topic's name. What is the topic name? It's in the definitions. What's the topic name?
Slope-Intercept Form.
Exactly, Slope-Intercept Form. And this is the second method that we are going to be using to graph. First method, input-output table. Second method, slope-intercept form. Next week, we're going to see the other methods. I think that's 2 more methods that we're going to see before doing another classwork, okay? And with that, it's basically the topic that we were going to be seeing.